Welcome to our comprehensive guide on composting crop residues and green mans. In this video, we'll explore the benefits, processes, and best practices for turning agricultural waste and green mans into nutrient-rich compost. Understanding composting. Composting is the natural process of recycling organic matter, such as leaves and food scraps, into a valuable fertilizer that can enrich soil and plants. The end product, known as compost, is a dark, crumbly, and earthy-smelling material that is a boon for gardeners and farmers alike. Benefits of composting. 1. Soil enrichment. Compost adds vital nutrients to the soil, improving its structure, aeration, and water retention capabilities. 2. Waste reduction. Composting reduces the amount of organic waste sent to landfills, thereby lowering greenhouse gas emissions. 3. Economic savings. By creating your own compost, you can reduce the need for chemical fertilizers and enhance the sustainability of your farming practices. 4. Environmental protection. Composting helps in the sequestration of carbon in the soil, playing a role in mitigating climate change. Crop residues and green mans. What are crop residues? Crop residues are the parts of the crop that are left in the field after the harvest. This includes stalks, leaves, and roots. Common examples include corn stalks, wheat straw, and rice husks. What are green mans? Green mans are crops grown specifically to be plowed back into the soil to improve its fertility. These crops, such as clover, alfalfa, and rye, are rich in nutrients and help in soil conservation and enhancement. Benefits of using crop residues and green mans in composting. 1. Nutrient-rich compost. Both crop residues and green mans are rich in essential nutrients like nitrogen, phosphorus, and potassium. 2. Soil health improvement. They improve soil organic matter, enhancing soil structure and microbial activity. 3. Sustainable farming. Utilizing these materials reduces the reliance on external inputs and promotes a circular approach to farming. The composting process. Step 1. Collecting materials. Start by gathering your crop residues and green mans. Ensure you have a good mix of greens, nitrogen-rich materials like green mans and fresh crop residues, and browns, carbon-rich materials like dried leaves and straw. Step 2. Preparing the compost pile. 1. Location. Choose a well-drained site that is easily accessible. 2. Layering. Begin with a layer of coarse materials, like straw or corn stalks to help with aeration. Alternate layers of greens and browns, ensuring a balanced mix. 3. Moisture and aeration. Keep the pile moist but not waterlogged. Regularly turn the pile to ensure proper aeration and decomposition. Step 3. Monitoring and maintenance. 1. Temperature. A compost pile goes through various temperature phases. The initial phase is mesophilic, moderate temperature, followed by a thermophilic, high temperature, phase where most decomposition occurs. Monitor the temperature to ensure optimal conditions. 2. Turning. Turn the compost pile every few weeks to introduce oxygen, which is crucial for the decomposition process. 3. Moisture level. Check the moisture level regularly. The compost should feel like a wrung-out sponge. Step 4. Compost maturity. Composting can take anywhere from a few months to a year, depending on the materials and conditions. Mature compost is dark, crumbly, and has an earthy smell. Test for maturity by ensuring the material is no longer hot and has a uniform appearance. Application of compost. When to apply. Compost can be applied during different stages of crop production. 1. Pre-planting. Incorporate compost into the soil a few weeks before planting to allow for nutrient integration. 2. Side dressing. Apply compost alongside growing plants to provide ongoing nutrient supply. 3. Mulching. Use compost as a mulch to retain soil moisture and suppress weeds. Application techniques. Spread compost evenly over the field and incorporate it into the soil using a harrow or similar tool. Apply compost in narrow bands along the rows of crops. Enhancing compost quality. Use a variety of materials to enhance the nutrient profile of your compost. Chop or shred large materials to speed up the decomposition process. Consider adding biochar, rock dust, or microbial inoculants to boost compost quality. Conclusion. Composting crop residues and green manures is a sustainable practice that enhances soil fertility, reduces waste, and promotes a healthier environment. By following the guidelines and best practices outlined in this video, you can create high-quality compost that will benefit your crops and contribute to sustainable agriculture. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more educational content on sustainable farming practices.